Yeah, my name is Simon, and I come from a startup game studio here in Malmö, where we make games primarily. We made board games and mobile games, and also interactive documentaries. Most of the game has been on a sort of serious topic. And then we are also right now working on, you could say, like more educational or games with a science background. So there is a lot of mathematics and physics in the game mechanics and in the sort of game theme for it. But today I will talk about our first VR game that we did. So it is a murder mystery game called A Most Curious Murder. So in the game you are Alexandra, who is the prime suspect of a murder case. And obviously you're innocent, and you decide that the best way to prove that you're innocent is to break into the police station, because the police is a bit lazy in your view, and they need a sort of nudge in the right direction. And you are convinced that in the police station there are surveillance video from the murder night that proves who the real killer is. So your objective is to break in, find the surveillance videos, and then solve the case for the police, basically. So it's the game when you play it is like a computer-generated world, fully interactive. You can walk around in it, and then we have surveillance videos which we filmed with 360 cameras that we placed in sort of high locations in a hotel room to mimic a surveillance system. And then we had actors acting out the day before the murder, and then the murder night, and then the sort of minutes after the murder when people come in. So your job as the player is to find the clues in those videos, and also some physical evidence that is in the police station that you need to find. Yeah, so we blend fully interactive gameplay with 360 videos. When we did it, it's a narrative game, so we wanted to really make sure that we don't break the immersion for the player. So that's why we did not want to use any of the sort of teleportation ways to move people around. So I will talk a bit more about that later in the presentation. And we have partnered up with a company called Adverty. So we have inside the police station, we have put up posters on the walls, like normal, like this, for example, in the virtual world. So it's like we've made a building, and then we lure people into the building, and we display posters with ads on those in a sort of non-intrusive way. I brought the couple of headsets so you can try the game afterwards and have a look at it. Yep. Yeah, I think so. If you can remember them, yeah. So we have released for the Gear VR, and then we are right now porting it to these integrated VR headsets. Our target audience is people that like narrative, puzzle, and exploration games, and also people that are sort of tired of the more standard rail shooters and horror games that are out there. Yeah, so this is some video from inside the game. All right, so that was 90 seconds from the game, roughly. So what I will talk about today is some of the sort of challenges and problems we run into when we developed it and also when we published it through the Oculus store. So our biggest challenge, I would say, is that the Oculus store requires 60 frames per second to be able to publish it, and then it's 60 frames per second for both eyes. So you have to render 2 images, obviously, because it's stereoscopic. Of course, they allow you to select which phones you want to publish for. You can say, I only want this game to be available for the high-end, like the newer phones. Problem with that is that the estimate from last year was that there are around 10 million Gear VR headsets out there, and I think a lot of them was sort of bundled with phones, so they're maybe collecting dust somewhere. So we really wanted to reach everyone that has a Gear VR headset and that are willing to play. So we didn't want to sort of leave any gamers behind. So then we decided we're going to make it work. All the way back to the Note 4, I think it's from 2014 something. It's a rather old phone. So these are the areas I will talk today about that we sort of worked with when we optimized the game. So starting with the lighting, we wanted to have a realistic environment, of course. But at the same time, we knew we were doing it for a mobile device, so we could not sort of afford a lot of dynamic lighting in the scene. So therefore, we decided we need to have at least one dynamic light, and we wanted to have that for the flashlight, because when you break into the police station, it's dark, it's in the middle of the night, and we wanted to have this effect that you sort of illuminate areas with your flashlight, as you saw in the video. So that was important for us. So we said, okay, that flashlight can be dynamic, but we need more light than the flashlight, of course. We want to have sort of ambient light coming in from the street outside, and we want to have different light sources in the environment as well. So you can solve that by pre-calculating the contribution from the different light sources on the different objects you have in the scene. Sort of, I mean, for all the static objects, it's quite straightforward. You can on your PC you pre-calculate it and save the results in these kind of light maps, which is basically like a texture which contains the contribution from all the different light sources onto that particular object or model that you have, 3D model. It's quite time consuming to generate on the computer, but then it speeds up the gameplay a lot once you have done that. Another thing we sort of kept in mind all the way from the start is the polygon count on the 3D models. So we wanted to keep those low, of course, to save rendering time. So I'm not sure sort of how familiar you are with computer graphics and polygons in here, but basically the polygons is sort of flat surfaces that make up the shape of everything in a 3D world. So, and due to that they are flat, you have to have quite a lot of them if you want to sort of mimic or model something that is round, like a ball, for example, would. If you want to have that perfect, it would be an infinite amount of polygons. But if you render like a die or a box, it's much easier. So what you can do then is to use this level of details, where you, for each 3D model, you start by modeling it in sort of detail with a lot of polygons, and then you create multiple versions of it with less polygons, and then in real time when the game is running you can switch between these multiple versions of the model depending on how far away the model is. And similar to the modeling of the 3D objects, we also want to sort of make sure we don't clutter the scene or the level with too many models, because that also, of course, builds up the polygons that need to be rendered for every frame. So here you can also use bake lights to sort of add more details, because when you strip away items, it can become sort of non-realistic and boring if it's not enough details in the levels. I'll also come to later why it's good to reuse the same model in multiple places in the same scene. Yeah, so a few months into the development, we had mostly been running on the S7, S8 when we did the testing and sort of the performance evaluation. So we got a hold of a Note 4 phone, I think it was, first, and loaded it up to see how it worked. And we hit around 30 frames per second, and the requirement is 60. For the Oculus, there is a fixed refresh rate of 60 frames per second or 60 hertz on the displays. So the whole rendering pipeline needs to finish rendering the next frame before this 16.16 millisecond deadline from the previous frame has elapsed. So you have to render everything and have 2 then frames ready to be displayed, or you will have to wait until the next one, which then basically you're directly halving the frame rate momentarily there if you miss this deadline. So having on average 30 frames per second, we knew we missed it a lot. Yeah. So then we started looking into draw calls in different areas of the level where we had the performance problems. And draw call is basically the preparation the CPU needs to do to load one or more meshes from one or more 3D models, you could say, into the graphical processor that later will render it. And then, of course, like I said before, all the 3D models of that view needs to be rendered before the frame can be sort of displayed on the screen. So you can see here, this is we were using Unity as a development tool and game engine. So basically we brought up this statistics. It's quite a simple tool, and run it on the computer, and then walked around in the scene, looking around in the game mode, and then sort of noting where we had performance problems in terms of draw calls. And we could see, I think we had around 200 draw calls in the worst cases of the level. Yeah. As I mentioned before, a draw call is you load one or more 3D model to the graphical processor, and it can load more if they share the same texture or material and shader settings. Then you can load multiple in one draw call, which speeds up the total rendering time. And we didn't want to have the same texture, of course, for different objects, because that would look strange. But then there is a way to sort of make a bigger texture that contains textures from a lot of other objects in this sort of atlas, where you have tiled the textures from the different 3D models, and then those 3D models can be loaded in a single draw call if they are in the same scene or same frame that you want to render. So that this is one way to reduce the draw calls. Another is something called Occlusion Culling. Yeah, I think you can see. So over here, you have the camera, and then these lines going out here is sort of the viewpoint, what the camera sees, and you can see there is nothing rendered behind the camera, because that's pointless. But you can also see that the camera is in this corridor, which is a closed corridor. There are doors here where you can see through, but there is no way you can see this area or the basement over here. That's sort of obscured by the walls here, but it's still being rendered. And that is because the pipeline, when it renders the 3D objects, it doesn't really know the relation between them in the sort of game level space, so to say. So it will just get a number of items to render and then do that, and then it will render it to the screen, and then it will overwrite what's behind, so to say. So what you can do then is to basically it's like a trade-off between not rendering stuff that is not visible at the moment, but at the same time not spending too much sort of processing power on figuring out exactly what is visible from the camera. So then you divide the whole scene into blocks, into cells, and then similar to these light maps I talked about, this is also something that you run on your computer, sort of building up a data set of the entire scene, where from each of these cells or blocks you build up like a hierarchy with the relations to all the other cells in the game level, and then each of the static items then belong to one of these cells, and then when you run the game, you can, depending on where the camera is located, which cell it is located, it knows which cells it needs to look for stuff to render, and which cells that are then completely obscured or blocked by other things, and then it doesn't need to render those. So the result you can see down here, camera in the same location, it renders this corridor and this corridor, and then parts of here, which is sort of, you can see through the glass windows in the doors. And this is a huge saver, of course. I mean, this makes a big difference. So using this occlusion culling, we noticed we had choke points coming into this big office space where we had a lot of stuff to render. And the original game level that we had a corridor coming straight in like this, with some details in the corridor, of course. And then we noticed as you were walking in the corridor, you're coming up to the office, and then you have to sort of, in the end of the corridor, you have to render both the corridor and the office. So what we did then was quite simple. We just sort of angle it at 90 degrees. So as you saw in the previous picture, see if I can go back. When you're coming here in the corridor, it will only render this part, which is that. And then as you turn around, the whole level opens up. So the level design as such makes a big difference also. Not only how much detail you have, but how you place it, so to fully utilize this occlusion culling. And then we did a similar thing when you exit the office to go down into the basement. Yeah. I think at this point we sent it into the Oculus store, and we were sort of happy with the performance. They did not think it was good enough. I think it was the S6 they were complaining about. So then we ended up doing some sort of, dirty tricks, or what you would like to call it. We simply put in a runtime check in the code, and then if it's on certain models of the hardware, we don't render things that are not essential for the gameplay. So you can see here, shares are missing. I think there should be some other, the water thingy, water cooler is not rendered, and we also disabled the real-time shadows for the flashlight, actually, to have some margin for those phones. And this was, we had set the release date before we had gotten an approval from Oculus, because that's what you do naturally. So then we had to sort of solve it in a quite short period of time. Yeah, another thing we also spent quite a lot of time thinking about is the sort of immersion, as I mentioned before. It's a narrative game, so that's sort of what we have going for us. It's a strong story, and we need to convince the player that you are in this police station when you're playing it. At the same time, we didn't want people to get motion sick, and that's for some people a big problem when you have a mismatch between what you see and what your balance senses sort of tells you is happening. Like if you're in a car looking down in a book, you see that you're sitting still, but your body feels you're sort of accelerating and braking and such. And for VR, it's the reverse. You see stuff happening, and you see yourself accelerating towards something, but you don't feel it. And then I think the sort of schoolbook or basic solution for this is to use teleportation in the game, because teleportation involves no acceleration. You simply move from one spot to another spot, and yeah, that's sort of, there is no acceleration there, so there's no mismatch for our body. It feels natural to teleport, even though maybe we haven't teleported in real life. It still doesn't cause this mismatch. But yeah, it doesn't really work for our story world. I mean, we're not in a spaceship. We're in a police station in present time, and there is no. Alexandra doesn't have a teleportation device with her, so we didn't want to use that. Yeah, so that's what I talked about. We want the player to be able to freely move around without teleporting, and then sort of really being in that police station in the middle of the night. So what we did is quite simply we force, or encourage the player to play the game standing up. I say we didn't force, because in the end we actually added a different locomotion system as well, because Oculus wanted us to give people a possibility to play it even when they're sitting down. So, but we strongly encourage people to play it standing up. And as most other VR games, you can look around, of course. And then to trigger sort of a movement in the game, you walk in your spot like this. And then we sense the movement of the headset moving up and down. So then you have sort of 50% of the real feeling from walking, because of course when you're walking you also walk forward like this, but at least we have your body's moving, so it takes away a lot of this mismatch. And I think we've had several hundred people play it at different game conferences and events, and a lot really good feedback. We have not had anyone throwing up in front of us, so it's positive. I think the next one is actually from it's from XR Connect this year in London, where you can see behind each other there's two persons playing the game. Yeah, I think we had around 5 or 6 iterations with Oculus. Like I said, we set the release date before we submitted it for review, thinking it would work similar to the App Store, Apple App Store or Google Play, which we have released for before. But it turned out they are a lot more picky than Apple, which was a surprise for me. But I think it's probably good. I mean, it's a new medium, you could say, and people that pick up a headset and play a game for the first time will sort of, if they play a bad game, they will sort of think all VR is bad, because they've not played any other VR games before, and then there's the big risk they will put it down and not come back again. So it's good, I think, that they are picky. So biggest problem was the performance problem on the S6 I talked about. Then we also had a debate with them regarding this, I call it couch mode. They wanted people to be able to play it sitting down, which at first we didn't want to give that option because we thought it breaks the immersion when you're sitting down playing with a controller. turned out we had forgotten copy protection, which they thought we should have. And then there were a number of these buttons on the headset related to the menu navigation that we had not implemented because we did not really have a menu in the game as such. But then they finally approved it and we launched it. So yeah, we learned a lot, of course. This was our first VR game. The biggest takeaway, I would say, is this one. It took quite a long time to get it approved for the Oculus Store. It's a quite extensive list of test cases they run through. They also have quite picky demands on the art for the store, and usually takes about 2 to 3 days. At least for us, it took about 2 to 3 days as a rather small new studio to get feedback on the review request. So that sort of adds up in time when you don't get it right the first time and then have to go through it several times. The other one that was a bit of a disappointment for us, we had high hopes of sort of monetizing this through ads, which didn't really turn out the way we thought. Partly because we have not been able to sort of reach out to enough players and get them to play it, but also because the ads works good if people come back, if it's a high sort of replayability of the game. The game has a lot of replayability. Ours is a narrative game, so when you figured out the story, the plot, there's no point to come back and play it again. Yeah, that was actually all I had to present today.